just a brief background on myself. I spent almost 10 years working at an ornamental nursery in production, and went out on my own about 9 years ago, and have been working on solutions to help growers across Canada, mostly in Ontario, but some of the issues have gone national. I work a lot in collaboration with Anne Huber from Soil Resource Group and our local Ministry of Agriculture, Jen Llewellyn and Siobhan Carlo, just to look at issues that are particularly impacting ornamental hort. So related to environment is one of the larger goals. So the project, the COHA-7 project that I'm the lead researcher on, is one that has been going on for about 3 years now, and so we're well into it. But we're not focusing on that, the sole research being done through that project today. This is more of a general discussion of the kinds of things that led us to that project and the things that we're seeing as we look at environmental issues. So there is evidence that there is an issue in the public eye. They have been alerted to concerns with water quality, particularly in the Great Lake region, but across the country. And there has been a link to agricultural activities that can be the cause of this. And so I think as farms, we can look at it from 3 levels. There's an aesthetic issue if you have a pond that is visible or surface water that's visible, or we're hearing about things in the news. That's a more public aesthetic perspective to look at. We're hearing more about regulatory concerns as a result, particularly of the Great Lakes issue, lowering phosphorus levels and having targets either at the provincial level or at a federal level, some goals to meet to prevent toxic blooms, for example. And we're also hearing individually from farms that, you know, they've got issues with irrigation water quality, with plant needs being sacrificed because of their quality of their water coming in, and micro irrigation systems requiring additional clear water that it's just not meeting their standards. So what are we talking about when we say we're seeing some issues on farms? So these are images that we've taken over the years that, you know, these are recycle ponds and recapture ponds that are also their source ponds for irrigation on farms. And there is evidence that there are lots of things happening that may make it difficult and plug lines. Here's an example at a greenhouse, a silo, which you'd think, okay, that's pretty clean water coming from the greenhouse going through a treatment system, but it's got a huge bit of green filamentous algae here that my colleague Anne is holding up. And we thought, yes, there's a bit of algal growth in here, it's not an issue, but we did a dye test to monitor flow rates through this silo and into our treatment system, and lo and behold, it had completely plugged the outlet of the silo. None of the water was going into the treatment system. So obviously this is a green alga, filamentous alga, causing a major issue, and took some effort to clean up. There are other cases where it looks bad, but actually this is a plant, Macrophyte mass, and it's actually doing a really good job cleaning the water, and it's not causing a problem. So just because it looks bad doesn't necessarily mean it is a terrible thing. And here's another situation where Anne's taking a sample of a very suspicious looking bluish green border around this pond. And sure enough, we did have cyanobacteria, which can lead to toxic excretions by those organisms. And that's a real concern for drinking water quality. Not necessarily an issue directly in an irrigation pond, but obviously a big enough concern when you're looking at overall water quality, and that these ponds can interact with the environment and lead out to other surface waters. Under the microscope, we thought it might be interesting for you to see this, just what we're seeing in water. look, diatoms, things that are quite normal and healthy. On the right, there's a couple of examples of filamentous green algae. So we have Spirogyra. It's kind of got a bit of a spiral look to it. And the lower right is I've lost my mouse, there it is. This is actually Magotia, which was the thing blocking, the algae that was blocking that silo outlet that I showed you a picture of just a few seconds ago. And on the bottom left, this doesn't look like much. These are little circles, but these are quite serious. This is Microcystis, which is a toxin-producing cyanobacteria. So we've found all of these things, among others, in the waters in ponds. So what do we mean by quality? And I'm just double checking something here because I've got, is everybody seeing everything okay? I think on the screen, let me know and in a chat if there's any issues, okay, with visibility on this. So what do we mean by quality? There's really three aspects. First is the biology. What's growing in your water? Is it algae? Is it bacteria or cyanobacteria? Is it fungi? Do we have plants growing in there? What's going on? And what's causing that? Chemistry, we're looking at water quality in terms of what your plants need, hardness, pH, etc. We're also thinking about what are environmentally more concerning issues, including nutrients like nitrogen and particularly phosphorus that can actually lead to an increase in what I would call nuisance biology. And physics may not be something that you concern yourself with on a daily basis at the farm, but water temperature, depth, flow rates, these things do impact the other features of water quality. So as researchers, we keep that in mind. So growers have to deal with water quality regardless of their source. So a lot of the farms that we work with, primarily it's a freshwater surface water source, which is why we chose this as the focus of the talk. But there are issues even with groundwater. You have to think about hardness and what else is in there. You might have salts or sulfates or something that are happening in your water, the pH. And also, if you're doing any recycling or recapture and reuse, you do want to think about plant pathogens as well as some of the other things we've mentioned. So where do we start? Starting with the source, we're going to do a bit of a walkthrough. I think, Rita, I'm not sure if you have that poll available right now. I don't know how that functions, if I have to stop. Are you able to jump in?
First is to unmute myself, sorry. And we're launching that now.
Great. And so are you able to, is everyone able to see that? So we'll give you maybe another 10 seconds or so if people can vote. It's your primary source water, and then you press submit. Okay. Give it a few more seconds. We'll go to 45 seconds just because it's the first one. Give everybody a chance to vote and press enter. Okay, and we can end that. And I think Rita will be able to record that, right, Rita?
That's right. And are you seeing these results now, Jeanine?
I am. That's working. So just so everybody on the call knows, this is a bit of a trial run on the spot. So we haven't been able to see the results because we didn't have attendees when we were practicing. So this should work. That's great. Okay, so you've got quite a few recycle ponds and surface pond waters. So that's super. Okay, so I'll move that off to the side. And I think to start off, I just want to remind people of some of the tools that are out there. that we have an environmental farm plan that looks at your entire farm. So it's best management practices, agronomic practices that include water management and fertilizer management, but it's a whole farm image. And this is generally available in most provinces and English and French. And there's also, to drill down on the water side of things, these awesome self-assessment guides that have been produced. There's actually 3. There's one for outdoor container production, one for greenhouse floriculture, and there's also one for vegetable greenhouse production. And I really encourage you, if you have not, to access these and to go through these and do that next level. And a lot of the discussion and questions in there will follow along some of the concepts that we talk about today: water coming in, water during production, and water leaving your farm. So that's how we're going to approach today, is to work through each of these pieces and to understand at each level what you can do, essentially. So this is just an example farm that I took off Google. It's nobody's farm in particular. And so we're looking at all the different options and how water moves through a farm. And we're going to start at the beginning. So what's getting into the source water? So you might have a recycling pond. I noticed some of you recapture, and that might be your source. And some people are getting source water fresh from a creek or other place that's coming, or groundwater, et cetera, where it's completely fresh to you. But that doesn't mean that nothing's getting in there, right? So you might have other field tile. You might have places on your farm where you've got runoff, et cetera, coming in. Loading dock or parking lot water can cause salt, things like increases, or you might have other waters coming from different components. So have you tested it? Do you know what's going in? We also know that geese are a real issue. There's a lot of phosphorus produced in waste product and deposited into your pond if you have these visitors, and that can significantly contribute to your water quality or lack thereof. We also see a lot of runoff or drain water coming off of farms. As sediment does bind, soil binds very nicely to phosphorus and will carry that along with other things into your pond and collection. So these are other things to think about. So monitoring and knowing what's in your source water is important. And I'd like to just show you a little example from a study that we did. It was a 2-year study a couple years back now. And I'm just not showing you a lot of data here, but I want to get you a sense of the variability. So in 2013, we had very low levels meeting all the Ontario targets. And there's different source waters here broken apart by red is sort of a general for everything together, but I separated off-farm surface water sources versus a recycle pond or a recapture pond and groundwater. You can see the variation over this year in phosphorus. This is total phosphorus, quite high over the course of a season. And then the following year, almost hardly any variability. It looks great. So you can imagine if you just sampled in May or June of 2014, you might not expect that there's a lot of phosphorus in your water. But if you had sampled the year before, you might notice quite something different. So 1 year of sampling or a one-time sampling is really not sufficient. Just some other examples of other elements that I know are really important to you. Particularly you see in groundwater, which is the top line here, the bicarbs can be quite high. But again, there's variability from year to year. So something to think about. pH. The error bars aren't shown on these graphs, but we do know that there was more variability as we got later into the summer. We've seen pH levels go up over 10 on occasion in late July. So these are some concerns that I know that you'll have about your own, what your plants want. Potassium as well. We do tend to see water quality deterioration over the season as heat increases, evaporation increases, and our water volume storage decreases. So just a quick summary. There's different source waters that we really need to think about how we're protecting it. Do you know what's getting in there from either prior to your farm or on your farm? And what can you do about it? So know what's in it and use those AMAFRA guides, which I'll do another plug for here. And we'll get into a little bit more detail about monitoring and testing as we go in the next section of the talk. And what happens during production? This is really the biggest area in my mind where you have control. You've got a lot of control over your fertilizer management and your water management that can really impact the water quality that you have ongoing and what could be potentially leaving your farm. And there are a lot of opportunities for direct going into your recapture pond, but also there's a lot of farms that are doing recirculating of certain water types, particularly from greenhouses in Ontario. I know BC, February 2020, last year, had new regulations put into place where they're going to have to be looking at their water quality much more closely. And Ontario has been working on this for about 8 or 9 years, pretty seriously. So it is becoming more of an issue. So I think it's good timing to have a reminder talk of just what we can do to manage those things. So the first, I think we'll focus on fertilizer management. That's a bulk of this talk. The 4 R's, really what type, what rate, the timing, and the place. And so we do have some projects that touch on some of these things. So are you using controlled release, for example? What's the rate you're using, the term, the release curve on it, and so on. And we'll talk particularly about placement and how that can affect what the nutrient levels are coming out. And just to note that we have noticed media and soil influences are quite important in looking at this overall picture. So that's where it's a whole farm approach. You'll see that as we go through. Nothing is independently the one fix. And so here's an example to highlight it. In the first data slide I showed you, it was all source water. So this is the next part of that same study. I'm just picking the 2014 year here as an example. But this upper left graph is drain water. So that's your runoff. So off of a container nursery. So you can see this, the red line is the ministry target in Ontario, and there's quite a lot of variability over the season. In the runoff, so in that leachate water that's coming off the beds, we are seeing nutrients. The bottom graph is what's leaving the farm. So this is after it's come to a recapture pond and it's overflowing to the environment. So going back to the lake or wherever. Looks great. No issues there. I wanted you to see this slide because this is where I think we have an opportunity. We're not doing terrible things. We are good stewards. So you think, okay, everything's great. My water when it leaves the farm is looking good. But I think we have a job we can do to manage what's happening at this stage. Greenhouse floriculture, I wasn't sure how many people on the call would be from that background and running farms like this. So I just wanted you to be aware we have done extensive study on this as well to look at various waters, from cut flower buckets, boiler water, condensate water, floor drains, and loading docks, and had a look. And I think the interesting thing was what we found where we didn't expect it. We knew that there would be, obviously, water coming off a bench is going to have a lot more fertilizer. They're using water soluble, and the plants need quite a bit more than what you would do in a controlled release formulation prill. From day to day, you're getting higher numbers, but obviously it's not expected to see it when you're planting, for example. So you might have a pre-charge in your media and think that it's not very much. And we were surprised just how much nutrient was actually in there. So these are total phosphorus numbers. Unsurprisingly, here's your nutrient feed water. So quite high numbers with a lot of wide error bars showing that the numbers can be quite high for what's actually coming off of a bench or on a recirculation system. So most of these waters are being recirculated, but just to be aware that even where there may be waters you think don't have a lot of fertilizer in them and might not be contributing, it's good to know for sure and to test them. So we're going to focus a little bit more detail, monitoring, management of fertilizer and irrigation, and we'll talk about some treatment options for the rest of the talk. So monitoring, I want to focus in on because I think I've highlighted already, there's changes over a year, within a season, changes from year to year. So really it's important to, at least for the first few years, I really recommend doing monthly sampling, and then you can move to quarterly once you have a sense of the variability at your farm. So not just source water, but also that drain or runoff water, as well as what's physically leaving at the outlet, at the edge of your farm. So the other piece of it is, I know a lot of companies that are suppliers, either fertilizer or media companies, they will come in and they will offer to do free testing for you. And I would caution you, sometimes there are great analyses and that's wonderful, but other times it's just, pH, EC, and a couple of little things. It's really not enough of a true picture of what's happening. So we really recommend using an accredited lab with a full sample analysis and looking at the level of phosphorus as a minimum detection limit, making sure it's low. It should be quite a low, 0.1 ppm, for example, for total phosphorus. And again, doing it at the right time, take a sample early and then we can get it out to the lab so it's fresh when they get it. And making sure you're sampling at the right spots. So get a pole, get into the places where that water's leaving your farm or leaving certain beds. So you might have an area that's field or a specific container area. Try to capture it at exactly those points. And this slide, I wanted to show you, don't take the bottle and collect a sample in the pond where the drain is pouring into. You're going to have that dilution effect with stormwater, etc. So make sure you're taking it. It takes a little longer, but get that dribble or trickle right from that drain source if you can. And a pole, you don't have to get a fancy one like this. You can make them yourself, and just a telescopic pole or a piece of, or a stick, and tape a bottle to it. So I think we have. Are we going to do this pole now, Rita? Are you able to pull that one up, Rita? There we go. And we'll let that go to 30 or 40 seconds. I think we get about 18 to 20 people reporting, so. Okay. That's great, Rita. I think you can end the poll. That gives us a sense. So there's a few people that are doing monthly, but I'm really I think there's value then. That does encourage me to push for the importance of sampling and on a regular basis. So thank you for that, everyone. And we'll carry on. So a twist, here I have been saying how wonderful it is, get all your samples tested and promoting monitoring, but I do want to tell you that there's a little catch that we found as we were looking at our data from the COHA-7 project. And this is my twist, and you know what I'm doing now in my spare time during COVID. So the current project, we've been looking for a couple of years now, getting some background data, and we've been looking at these recapture, recycle irrigation ponds, and go figure, like I showed you that phosphorus level, nice, beautiful, low levels, but we're still having problems. So there are some cyanobacteria blooms, there's some filter clogging, we're having some filamentous algal blooms show up. So just because that initial water quality paper analysis you get looks terrific, it doesn't mean the water quality is really giving you everything you need. So we are looking at some other options for measuring water quality more closely, getting better measures of it. So do we need to look at phycocyanin, which is the pigment in the blue-green algae? Do we need to look at chlorophyll levels? What else are we looking at? Soluble reactive phosphorus and some other things that might make a big difference in terms of truly telling us what our risk is for either nuisance biology or potential clogging of irrigation lines. So two of the things we're going to focus mainly on, again, the fertilizer piece of what's potentially what you're using and how it's placed. So we'll talk a bit more about that. And we'll be talking about some water management in the next step. So the first study we did a few years back, we looked at fertilizer placement. So we adjusted the rate a little bit. We did a little less on the dibbling, but the focus of it was to look at placing in pockets by dibbling, top dressing, and incorporating, and looking at the leachate. What's happening with that leachate over the course of a season? So we did this at 3 farms, and we had the same Weigela crop host plants for the study in all the same size pots, same treatments across the board. However, the irrigation systems at each farm were different. And the media, of course, we used the media that each farm particularly used. But we did all the potting ourselves and all the leachate tests at the end of every regular irrigation events. Not everyone. There was a lot of intensive work there. We saw some root variation, which I'll show you. We know that we've only tested one plant here, one genus. So of course, things may not always work and across all plants. And we had good growth, except for the odd discoloration seen when we tried to add in some phosphorus sequestering elements, such as wollastonite or alum and zeolite. Media differences did have an impact. But generally speaking, I think we want to, this is the graph that really speaks a huge volume to me of information. The source water, our total phosphorus levels, quite low. These 3 lines here are what's leaching out from the pots. So this is what you would be seeing in your drain or runoff water. Top dress and dibbling, you're going to have some, but it's fairly low. This is total phosphorus again. But the difference here, almost 50% more total phosphorus coming out of pots where the fertilizer was incorporated. So of course, these are control release prills, but what a difference. Same time frame, same particular fertilizer, just the actual placement is the real difference here that shows an absolute difference in the amount of leachate depending on the placement of that fertilizer. There were differences in roots. I've got a couple of different visuals here. I don't know if you can see there's some green prills right here and a massive root near that. This is the top dressing, heavy roots at the top. And this is incorporated where there's a fair bit of mass at the bottom. And once we washed them, you could see it a bit more clearly. Certainly the root structure was impacted, but no negative impacts. Overall root growth was healthy, substantial, and the tops certainly had no differences in the shoot growth or in tissue analysis that we did. So summary, we really saw an improvement in the amount of phosphorus leachate. We were able to use less fertilizer and have similar quality with the dibbled and subsurface fertilizer applications. So this is going back to those 4 R's, really showing us that there's something to think about in terms of placement, not just rate. People have asked how you do this, and there is an extra step, of course, over having it delivered with incorporated prills, but there are ways to make this happen in line or manually. And typically, of course, this is in the first year. Second year is more common to do the top dress. So overall, no water soluble outside. Make sure that those control release prills are in the pot. Obviously, we have seen situations where they're outside the pot and that makes it worse. But where to put it within the pot? At the top, wherever you can. It's always a better option. For floriculture growers that might be on the call, we also looked at micronutrients. And when you're sub-irrigating, there's standard rates, just like for control release and nursery product, there's standard rates that the supplier and fertilizer companies will give you. And it's a good thing to question if that's really what your plants need. Sometimes they need more, sometimes they need less. So molybdenum is one element that we were concerned about with recirculating in greenhouses. And we certainly don't want molybdenum leaving the farm. So we looked at the opportunity for decreasing the amount of molybdenum. So we used the same amount of molybdenum in water-soluble fertilizer for this poinsettia crop, from the beginning until early September. And when they started to transition to the reproductive phase, we removed the molybdenum, and then we actually did it in 0 molybdenum added up to the full rate with a range, every 20% increments. And at the end of the experiment, there was absolutely no difference. We did everything, tissue analysis, shoot weights, root weights, everything, 0 difference. So really it was quite clear that decreasing the molybdenum after that transition phase was perfectly acceptable. And it just makes you realize how important it is to think about every step. What do my plants need? Macronutrients, micronutrients. Am I really giving them more than they need, or just what they need, or too much? Okay, and we have another poll here, Rita. So are you able to pop that poll up? Perfect, thank you. Hopefully everybody can see that. Okay, and we're actually going to do 2 polls at once. We'll be a little ahead of ourselves on the next one, but first one is, what fertilizer management techniques do you use? So you can use, you can click multiple of these selections. And so I think on this first question here, and I'm not sure if you stop being able to see that if I scroll up, but there's a second question, and you can answer only one of, you can choose only one answer on that. And you won't be able to submit the poll until you complete both questions. And we'll just wait a few more seconds here because there's 2 questions involved here. Okay, we're getting around 20 people. I think we can close the poll now, Rita. Thank you. And hopefully that gets saved. So thanks everybody for contributing to that. So primarily we've got a lot of control release fertilizer use, but also quite nice to see dibbling, mulching, low P chemistry. That's a rare one that a lot of people don't use, which is wonderful to see that happening there. So, and we'll get into some of the irrigation techniques as well. Okay, we can close that. All right, so as we get into irrigation, water management, just a quick discussion of this. What do your plants really need? And of course, this is always going to be balanced with, if you give them less water or you do the watering differently, you need to know what's happening in your media. And you also need to know what's happening with your fertilizers. So if you're giving them less water, maybe the fertilizer amount that you're starting with, the rate has to go down a little bit or has to change. So all of these things are interconnected, but keeping that in mind, there are some direct things we can do with irrigation and water management. So cyclic, how uniform is the application, etc. So there's lots of things that we're going to touch on here. Grouping and spacing. If you have to balance the production efficiencies and your quality of your plant production with managing water. Can you group them together by watering need? I know some farms are very active in this. Managing the spacing is tough. I know, space wars, and but also, managing how good that uniformity is when you have plants laid out. So we did a study another summer where we looked at uniformity in with overhead irrigation and sprinkler heads, and 60% or better is incredibly effective, surprisingly. But it's just, I think the important piece is understanding the more efficient it is, the less time you have to water to get all the plants around the edge. So therefore, overall, you've got less leaching happening and less potential for nutrients to move out of your pots. Bringing down your water use also can be accomplished through cyclic and pulse watering. Can use a lot less water. You need specialized pumps for some of this, and it's always wonderful if facilities are able to bring in automation or evapotranspiration models to manage their watering. And I know there are some that are working on that. And we did this poll already, but just it was really a sense of how far are you? Are you just plunking your watering on for so many hours every day, regardless, or are you really investing a lot of time understanding what you can do, what needs to be done, what my options are in terms of managing that water? A lot of you actually sat in the C section, somewhere between A and B. So, so there's obviously some things to keep your eyes open for, what you can do. Other conservation BMPs and thinking about long-term, how do you keep your water quality good? If the more you can collect up front in the spring and from winter runoff, often you'll be able to have better quality water for later on, as we know that it does deteriorate over the season. And how many people have on-farm water storage? This is a question that's a poll question again, Rita. I think it might be the last one. You'll probably be relieved to know. But it's good to, we thought it would be good to have everybody keep thinking about it. So continuous with groundwater. So your pond's not lined, your groundwater and your surface water kind of connect. Lined ponds, unlined ponds, but not affected by groundwater, silo and cistern, or no storage at all. And I know there are some farms like that, particularly if you're have a municipal source or groundwater source that's quite positive, quite healthy. You don't need it. Okay. Getting close there to a good number of people. I think you can close that. Thank you, Rita. That's great. So quite a range of sources and potential water supply storage options. And as you can imagine, the last few years, we're really seeing that storage is helpful on farm. And another aspect to it, it's not maybe as obvious, but it's a best management practice. Prevent the obvious from reaching your pond. So secondary containment, if you have water soluble, pesticide storage, etc. That's vigorous. Okay, we've gone through source water. We've gone through production waters. And now what? At this point, there are still solutions, but hopefully you've seen that there's a lot of opportunities for management before you get to this last point. But generally treatment is the last piece, or recirculation, but sometimes combined with a treatment system. So, you know, I think what the biggest question is, if we're treating, what are we treating for? So if you're recirculating, you might have different needs. Maybe it doesn't matter what the chemistry looks like, but maybe you're more concerned about pathogens. If the water is being discharged, maybe the chemistry becomes more important because you want to make sure that there's no nutrients in it as it's leaving the farm. So these are things that we think about. So I'll just quickly go through the last series of slides here to highlight some of the opportunities for managing water that's heading out. So particulate management, sediment ponds, settling ponds, filtration strips, generally for particulate matter, not for managing nutrients, but very useful. Cloth or screen filters can be used. And there's a bunch of other ones that I probably won't spend much time on here, but in the interest of time, but HTS stands for Hybrid Treatment System. So a combination of woodchip bioreactors and constructed wetlands that Anne's been heavily involved in designing. And we'll also talk about some of the treatments that we're testing out in the COHA-7 demonstration study. So here's a woodchip bioreactor, very deep, 6 feet, very effective at denitrification, so removing nitrate and N. It actually does remove a bit of phosphorus, but the focus is the nitrogen. And also what we've found, when there's low oxygen levels, when it's fully saturated, it kills all the pathogens. So this farm is recirculating this water back to use in the greenhouse and is very pleased that there's no pathogens in it. Here's another situation where it's the constructed wetland side. So gravel and I think sand, filter sand, planted with a manifold system on above and then planted on top. This upper right photo shows after it's been growing for a while on top. And this farm is taking polishing the water and taking color and tannins out of the water, because they have a UV filtration system that doesn't work when you've got brown water going past it. So this is working extremely well. We're also looking at options within the project to try some parking lot systems, stormwater capture. So we haven't installed that yet, but this is one of our goals. So this is just a stolen image from the city of Calgary. We are trying at garden centers and in staging areas where farms have mulch beds and they're putting their daisy baskets or wire baskets out. We have 2 cells here that are segregated from the rest of the bed. One just has wood chips, and the one on the other side of my daughter here is has some slag in it. So a waste with a higher amount of iron in it that binds phosphorus quite well. So we're going to be doing some more work on this next year, but we have some preliminary data for that. We're also trying a new site. This is combining. So this is that hybrid treatment system where we're putting in Woodchip Bioreactor plus constructed wetland, but this is going to be extremely shallow. So this is for after pre-pond, before going through wood chips, slag and gravel, but in a very shallow 1 to 2 foot bed, and allowing the natural grade to let that water from container production flow through that to remove the particular nutrients. We're not concerned about pathogens at this point, so it's the focus is different and the design is different. And the study that we did for the for the COHA-7 project, for in pond, we did 2 types. One, we did enclosures, or what we call mesocosms. We tried a number of different treatments, and I'll show you what those look like. And we did some sort of larger in pond treatments with Phytolinks and a Nanobubbler. So we've got some, I'll show you some quick examples. So in pond enclosures are essentially tubes that we set down into the water, and they have a floating ring at the top to keep them at the from all the way through the water column, and we can put treatments right inside the central column and compare that so that we're sort of doing treatments within a pond, and they hold about 1 or 2 cubic meters worth of water volume. So they're bigger than doing it on a lab bench, and it's right in the pond. And you can see here, we've got several around the dock after installation with a control cell. You've got the pond as sort of your main control, but a mesocosm in pond enclosure control, and duckweed and macrophytes and so on, as well as you can see the aeration bubbling up here on the right. And we did this at a couple of sites and tried a couple of replicate treatments at different sites, but also this pond in particular had a wollastonite, a phosphorus binding media installed in one of them as one of the treatments. And we also tried larger scale, mentioned Phytolinks. So this is what the structure looks like before it's planted up. It's a floating island, and it sits in the water fully planted. And we did, you can't just do a cell. So we did right in the channel of the pond. It was a narrow, long, skinny pond. And we had 3 channels. So the center one had no Phytolinks in it. And it worked great until, as you can see further on down in the season at the bottom of the slide, the water level dropped, and it was very difficult to get much out of that for samples. So we're hoping next year we'll do a better job with water levels. But ideally, those Phytolinks are used in sewage ponds and extremely effective at taking out nutrients. So we do have high hopes that we'll get some good results out of that. Another system was a Nanobubbler installed at a large irrigation pond. And so we actually chose to use these mesocosms or in-pond enclosures as the control. So there's 3 of those installed sort of throughout the pond as control sites for samples. I do see a question there, so hopefully everything is okay. We will address that later on. And Rita, let me know, please, if there's a concern there that with the presentation. Pontidaria is a plant that does really good job in shallow waters, grows well, looks beautiful, and will take out nutrients. So we've tried it last year for the first time, and we'll be doing more with that next summer. So I am essentially at the end here, I want to just go back and step through the key pieces that we talked about. Using the tools that you have out there, the environmental farm plan, but particularly those self-assessment guides. Understanding your water quality, doing the monitoring frequently, at least initially, so you really understand the range of your water, your source water, what's coming off of your beds and your growing areas, and what's leaving your farm. Particularly important to understand what your contributions are within your farm. You have an opportunity to make big differences here between managing fertilizer and managing water. So thinking about some of those trials that we did, can any of those ideas be implemented at your facility? And where there are discharges, or if you have irrigation issues, there are options out there. So feel free to reach out, and we're going to provide some of these resources here. And as you know, this presentation will be recorded and the slides will be available, I think, in PDF form on the COHA website. So please feel free to reach out, of course, to any of us on the team, myself and Huber. And if in French, we've included Julien, who's on the committee as well, and he'll be giving tomorrow's presentation. But there's some excellent, this is hardly just the tip of the iceberg of some of the great resources that are out there. So we really encourage you to reach out and look for more options that might work out on your farm to manage these things. So again, thank you very much. And I think I will stop screen sharing now and allow the next portion to open it up for some questions.
That was great, Jeanine. A lot of information there. And I do see a couple questions. The first one came on the chat from Jason. And his question is, why is the freshness of the sample relevant? Once it's in the sealed bottle, would it not be safe to presume the nutrients will not change?
So they can. So we have noticed pH differences, and some elements can actually stick to the walls of the bottles. So there can be changes in the water quality. So fresh is important. We do recommend that it gets to the lab within a few days.
Okay. The second question was from Bart. It was what is a Coco disc?
Oh, so sorry if I didn't put, there are cocoa fiber mats, and they have a slit in the one edge, so you can put it around the trunk of your plant and it covers the rest of the top of the pot, like a circle, and you can buy them in different sizes. It keeps water in. It often, if you're top dressing, it is a pain. You have to put it on after you top dress or lift it for the second year. But what a huge improvement in keeping the prills that are top dressed or near the surface, which is, as you know now, a great place to put those prills, keeps them in the pot. So it's good for water management, and it's great for keeping those top dressed prills where they're supposed to be.
Okay.
And weeds.
Okay.
Don't
and
forget
weeds.
about keep the weeds down.
Good point. Yes. The next question is from Kessel. I'm believing that's Chris Kessel, maybe. Were there any differences in root and top growth biomass between the top dress, dibble, and incorporated CRF trial? If so, what were they?
I would have to go back and look at that data and get that to you. So if you want to reach out to me privately, I can surely pull those actual numbers up. But in broad terms, no, there were structural differences in the roots, but overall mass, not biomass itself. No, definitely not in the shoots. The shoots were very equivalent, but for root growth, in like structure differences, but very healthy and similar in terms of weight. It was really interesting how they pocketed to different parts of the pot, though. I hope that answers enough for now, but feel free to reach out if you want more detail.
Okay, and another one from Jason. Where do the nutrients go in a Woodchip biofilter? Is nitrogen and phosphorus volatilized into the atmosphere?
The nitrogen is, Anne is the expert on this, but on the simple level, nitrogen is converted to to gas, but the phosphorus actually, we think, depending on the wood chips you use and the preliminary concentration of phosphorus that's reaching the wood chips, there's some ability that it actually just binds to the surface. So it's physically, I think that binding capacity or sites would decrease over time, but we are seeing quite substantial, 30, 40% easily phosphorus binding and removal out when we look at the effluent coming out the other side of a wood chip. So it's certainly doing something, but it's not volatile in that case. They're acting quite differently. One's physical, one's biological.
All right, I think we got 2 more questions. I think we can get through them all. This is from Rihanna. Hi Jeanine, Rihanna here from Qualitring, BC. Do you know where I can purchase the dye you spoke about at the beginning of the presentation?
Yes, absolutely. So I think you know how to get a hold of me, so feel free. I can email that to you. But it was a rhodamine dye that we had a bit of headache with. Anne's probably killing herself laughing right now because it wasn't a really pretty day. We did this several times to try to get it to work, and that's when we found out we had a plug though. So it was very helpful. So it's a rhodamine fluorescent tracer dye. And was the idea was to watch it as it went through our treatment system so we could get an idea of retention times. Quite slow, as it turned out.
There you go. And one more question, and it's from Janet Hill. Why have algal blooms in example Lake Erie North Shore areas increased in amount so much in recent years? More growers, more fertilizer use?
Actually, neither. I think there's an international joint commission between US and Canada. Ontario is obviously one of the big players on the Canadian side, but there's several states on the American side very concerned about this. In the 70s, we used phosphorus containing cleaning agents. We looked after that. We brought down the phosphorus levels in a big way in Lake Erie. It really made a big difference, but we're starting to see these things come back. Has fertilizer use by agriculture really changed that much? Have we gotten that much bigger? Are we less good stewards? No, I don't think so. I think it's not only phosphorus that's being loaded in actively, it's phosphorus that's sitting in the sediments that can be brought back and be made available through different activities. There's biology in the lakes that are making this happen. It's temperature. We're getting differences. We don't have the snow melt and the volume of water coming in from upper Great Lakes. So I think there's a whole bunch of reasons. That doesn't mean that agriculture doesn't have a responsibility. We do have some very serious targets in the International Joint Commission, particularly on Ontario, to reduce our phosphorus loading by 40% for every sector. So very big challenge. But certainly we do think that sediment, even in a ditch, water coming down a ditch, coming off of farms can carry more phosphorus and add to that loading. So that's why there's a lot of pieces to it, and there's a lot of research being done right now to try to understand just where we can make a difference and why we're still having blooms and why they're coming back.